Okay, we are about to get into the rules for expanding logarithms and condensing logarithms over this next little bit. So we're going to start with expanding. That means we're going to break it down into logs that we can work with. Today, we are just doing it just to expand it and practice with that. But the reason behind this is so that you can simplify the logarithms to the parts that you can work with. And so let's go over the basic rules. And these all tie back to the exponential rules. Because remember, these are representing the exponents. So if we multiplied the bases, we would have been adding the exponents. So, and anytime you're having a log, that is the exponent. So if we have log base b of m times n is the same as log base b of m plus log base b of n. So let's look at this with real numbers. So log base 3 of 8 times y is the same as log base 3 of 8 plus log base 3 of y. So if you're multiplying, you'll end up adding the two logarithms, and that logarithm is going to be written twice. If you're dividing, we subtracted our exponents, so we're going to subtract the logarithm. So if we're dividing, we need to subtract. So log base 7 of x divided by 5 is going to be log base 7 of x minus log base 7 of 5. And so your numerator goes first, your denominator goes second. If we have an exponent being raised to a power, we would multiply those. So we would end up multiplying the exponents. So we would have, bring it to the front. So 6 is going to move to the front, and that's going to become 6 times log base 4 of z. Because remember, this is an exponent, so we're multiplying those exponents. So that's the first 3 rules, and we're going to spend some time just working with these 3 rules, and then I'll introduce the other set of rules. So if I was to take this problem, what's separating it is multiplication. So if I was to expand it out, I would need a logarithm for each thing that's being multiplied. So log base 5 of 3 plus log base 5 of x plus log base 5 of z. And that's it expanded. So here, there's a couple of different operations. We have the division, and so we have log base 3 of 2x minus log base 3 of our denominator, which was y. Now, I need to look at my numerator. There is multiplication that was happening here, so we need to separate that out by adding. Oops, log base 3 of x. So that's that orange split apart. And then our subtraction of log base 3 of y. So here we have multiplication and we have a power. So to separate out that multiplication, we had to add. Now to move this take care of this power, I need to multiply it in the front. And so I'm just going to bring down that log base 12 of 5. Now, on my second one, that 2 moves to the front times log base 12 of x. And that's completely expanded. So here, we have 3 things that are being multiplied, and these 2 have powers. So let's go ahead and finish up the way it would need to separate if it was being multiplied. So separation from multiplication is addition. So log base 3 of y to the 8th. Now let's focus in on the ones that have exponents. And those exponents are going to move to the front. So log base 3 of 6, there was nothing being done there, so nothing changed. Plus 8, because we moved that, not 8, 3 times log base 3 of x. And let's look at this next one. The 8 moved front, 8 times log base 3 of y. So let's look at this one. This is going to go back to what last week we talked about, that we can change something from a square root into an exponential, and that square root is the same thing as x to the 1/2. Now that we have it as an exponential, we can bring it forward, and so you would have 4 times 1/2 times log base 10 of x. 4 times 1/2 is 2, so 2 log base 10 of x. Now, I said that there are some other rules, so we've already talked about these first 3. Now let's go into the last set. And I'm going to show you why each of these work. So you have log base b of 1. We want to figure out what that's equal to. So if I was to fish it, it'd be b to some power is equal to 1. What is it you would have to raise b to get to 1? Answer that in the next box. The answer was 0. Anything to the 0 power is 1. So this is understood to be 0. Now let's do this next one. What would I need to raise b to get back to itself? The answer to that is 1. Let's look at this next one. B to some power is equal to b to the k. Well, these would have to be equal. Basically, when you see this, it always ends up being just whatever the exponent is. The b's will cancel out. And same thing here. If you have an exponent being raised to a log with the same base, those cancel out, and it's going to leave you just the k. And for all of these, and I didn't mention this earlier, it's just whenever your base is greater than 1. And same thing with your numbers, they need to be greater than 0. Let's do 2 more, and then I'll let you start working on your side. 2 more with me, and then you'll have some of the answer together. So let's go ahead, and we need to first go ahead and separate out the multiplication. Log base 5 of 11 to the 6th plus log base 5 of the cube root of 2. Now, I separate it with addition because it's being multiplied. Now let's get that 6 moved forward. Is that 6 times log base 5 of 11. Well, on this another one, I have trouble since there's no exponent here. So I need to convert this into exponential first. So I need to change that log base 5 of cube root of 2 to remember how that's going to look. So remember, it was power over root. And the power here is 1, so that's going to be 1 over 3. So that's 2 to the 1/3. Now I have an exponent that I can bring forward. 6 times log base 5 of 11 plus 1/3 log base 5 of 2. Now, typically you're not going to see this written this way. I'll show you how it will look whenever you see it in problems. Instead of written as a 1/3 in the front, they typically write it as a 3 in the denominator. Log, I put a minus equal sign there. Base 5 of 2. So these are the same thing, just written a different way. You'll see it one of these 2 ways. Let's do one more together. So we have a power on the outside, so I'm going to go ahead and bring that forward. So that's 3 times log base 4 of x to the 5th divided by y. Now I need to split apart my division. When I split apart my division, it is going to separate with a multiplication or with a subtraction. But that 3 is hanging out in front. So that 3 is going to get multiplied to everything that I do. And so I'm going to go ahead and separate this out with the subtraction. So log base 4 of x to the 5th minus log base 4 of y. Now I'm going to use my distributive property, and that 3 is going to get multiplied to both pieces. Three times log base 4 of x to the 5th minus 3 times log base 4 of y. Now notice there's another exponent, so that 5 needs to move forward. So you have 3 times 5 log base 4 of x minus 3 log base 4 of y. 3 times 5 is 15 log base 4 of x minus 3 log base 4 of y.